All right, my friends. Shh. So you know, this is where we are. 2 pieces today we will finish up. Lymphatic system, urinary system. Sir.
If we get 10,000 retweets, can we not take a
10,000.
Oh, let's do it. Oh my gosh, I've always wanted to be one of those people. Okay, but can we just do like 1,000? Can we do like 5? Can we do 100?
No.
100 retweets, no finals?
No.
Oh, that'd be so much fun.
The question would be, what would we retweet? That'd be the question. What would be the...
Mr. Hess is amazing.
Mr. Hess is the best teacher ever.
Yeah, we'll retweet.
Well, if you really feel that way, you're not doing it just for the points. Okay, good. Thank you. Moving on quickly. We're going to start off with chapter 14, which is the lymphatic system. And you see there's 2 pieces that you need to know. What is the function of it? And then briefly describing how immunity works. So we're going to talk about those 2 things. And there really should have been an S on that function. It should say functions, because there are 2 main functions of a lymphatic system. If you are in chapter 14 on page 378, you should be able to see what that lovely function is. So let's start with that. 2 functions. Whoa, what in the world just happened? 2 functions. What does it say? 378. How about I'll pause and you read those first 2 paragraphs there under Introduction, 14.1. Play the Jeopardy theme music while you're reading. Right? Those first 2 paragraphs. Is this too loud? Is this too loud? Gotcha. Paul looked like she was in pain. I thought it was from me. But it's okay, first function is what? Transport excess fluid. Spaces. So can someone translate that to English? Okay, what is interstitial space? That's a good thing. In between what? Not organs. Even smaller. Even smaller. Between cells. Between cells. It's the spaces, these fluids that are in between the cells in our bodies. So it's transporting fluids, which we call lymph, and it's moving it from between those cells and taking it back to the bloodstream. Because remember, the bloodstream is not just blood, right? There's other water and nutrients and all those pieces that were in the blood. So it's dumping it back into that. And that's what this system, this picture here, is describing that thing. You've heard of these things called lymph nodes? Yeah. You know, you go to the doctor and they feel underneath your throat, thank you. Oh boy, your lymph nodes are swollen, right? Sure. Well, no, they are kind of... Right, they get either blocked or they get irritated, they're inflamed, right? This is a sign of your immune system working, which is number 2 function of the lymph system. Number 2 function is immunity. Not like immunity like you're not voted off the island in Survivor, but like to prevent you from getting sick, right? So transporting fluid is the first thing. And immunity, to protect you from outside things, right? So bacteria and viruses and harmful chemicals and all that kind of stuff. But also inside things. When your cells start to go wrong, what do we call that? When your cells go wrong, it's what, Sandia? Cancer. That's all cancer is. A cell that has been in some way changed or mutated that is no longer doing what it's supposed to be doing.
Why is it so much more frequent than it was?
I think that we are much more aware of it than we used to be. There's also just a whole lot of crap in our world, to be honest. A lot of things that will cause damage to these cells, which then causes them just to replicate out of control. That's basically what a cancer cell is. For some reason, the controls that determine how it replicates get messed up.
It seems like mutation is like, I feel like you have to go to stage to stage to stage to stage. Like, it's such a high thing to get.
Mm-hmm.
People get it so frequently. Like, you'll see somebody who's eating like really well, really healthy, get
True.
cancer and drop dead in like a month.
Right.
And then it's over. So like,
Can happen.
when something that drastic come out of something that's probably really minimal.
Mm-hmm. Right, you're talking about very small little things. But it all depends on how aggressive that cancer is. What kind of cell was messed up? Because some cells divide much faster than others. Some cells are much more spread out throughout the body than others. So it really does depend on what it is. But yes, you're right, it can be a powerfully quick thing. Oftentimes, though, it was present before that, and they just didn't know it. It just took long enough to get symptoms enough that they recognized it, and then you're right, quickly they can die. Not always. We're talking about the extreme examples, but yes. Your question, Sandia?
If, let's say, like, a whale has more cells than a human, how come we have more?
The problem is that the whale hospitals don't report very often to ours. There's not much communication between. Yeah, I'm sure there are. In the animal world, they do see that. But, see, I mean, whales are a good thing. Don't get me wrong. But yeah. So yes, we are not the only things that deal with cancers. No. But we don't really care about them as much. Has anyone had pets who have had cancerous tumors or other things removed, or known people who have had these? Oh yeah. I mean, it happens. So it's not a strictly human thing. Okay. Let's keep. Do I think sleep does? Well, what does sleep do for our bodies? It's the rejuvenation, it's the restoring, it's the healing process. So absolutely. Yeah. I'm not going to say that there are studies that have shown if you sleep less, you are more prone to cancer, because it'd be a very hard causation, but it would make sense to me, right? If we're consistently sleep deprived, our body doesn't have the chance to recover and refresh and heal. Yeah. It certainly affects a ton of other things. So you have these little things called lymph vessels. These little, that's what these green things are supposed to be here, that are intertwined. You can see them like all through the capillaries. Remember, capillaries are the space where the oxygen is exchanged with the tissues, right? Oxygen goes out, carbon dioxide comes in. Well, these lymph vessels are kind of all intertwined there. And so they are also going to then draw out that extra fluid from between the cells, transport it in this big system. Let me go down a spot here. Transport it in this big system. Like these are the lymph nodes and the lymph vessels throughout the body. The little dark spots, the circles, those are the places where these lymph nodes are most present. The big ones are underarms, right in between the thighs, not in the actual genital area, but in that in-between spots there. Your elbows through your torso. Those are the main pieces. And it flows toward the center. You're moving toward the center of your body. Because again, that's where the central veins run, trying to dump that lymph back into the venous systems. Here's a close-up of one of those lymph nodes where they're producing these macrophages and T cells. These are things that help with immunity. We'll talk about that a little more in a second. Here's a little close-up spot of where you see more lymph nodes. Definitely a significant area in the female breasts as well. Guys, a little bit, but much more in the females. Okay. Any idea why perhaps these lymph nodes seem to be congregated around like joints? You see what I mean? Like there's like shoulder, in your underarm, in your hip area, in your stomach area, in your elbows. There's some in the back of your knees. Any idea why that might be the case? Okay, there is fluid in the joints between the different bones. I like that. So they're going to play a role there. Why else? Okay, you move those a lot more. Well, these don't necessarily deliver oxygen. Remember, that's what the blood supply is for. But the moving piece is a huge part. How does the blood circulate through your body? Like what causes the blood to circulate? Your heart beating, right? We got this pump that's pumping, and it's putting pressure to push this blood through our system, right? The lymph system doesn't have any active pumping mechanism. It's a passive system. So therefore, you want to put these places that kind of are the centers of that system in places where we're bending and moving consistently. So that just simply me bending my elbow is going to squeeze that lymph up my body. Me bending my hip is going to squeeze that lymph and push it up toward the center of my body. Does that make sense? Like a toothpaste tube, right? When you squeeze on here in the spot, it's going to go up toward the top. Unless you squeeze in the center, then it goes both directions, right? But that's the point here. It's a passive movement. It's not an actively pumping system. When that goes wrong, you get things like this. Can you see? So here's a regular leg, and then look how much larger this one leg is. The same thing here. Regular size leg, can't see it as much there. Nice, big, huge leg. That is called elephantitis. This lymphedema. That would be a much more severe case. How does this happen? Well, sometimes post-surgery, those lymph vessels get cut. Like, I'm just cutting through, and I'm not going to worry about that. I'm worried about the nerves and arteries and that. But maybe they get blocked. And so therefore, you get this accumulation of that lymph, that fluid, in this one leg, one extremity. It can. It's tough, to be honest. Sometimes you just have to deal with it. But they do, as physical therapists, there's a massage type stuff that we do that try to move that lymph out. There are these tights that they wear, these very compressive stockings to help give that pressure to push that fluid out. Yeah. That's not too, the one on the far right is not too extreme of a case. But yeah. And it gets much, much worse than that. This is actually a fairly decent picture, but you can get these big nodules, and it's very, very gross looking. Not a fun disease at all to deal with. Okay. So from there, let's go here. Well, we'll talk about these things, this immunity. And boy, I'm telling you, I am just barely scratching the surface as far as this goes. We did, yes. So you've got these basically two main types of cells that work for immunity. You have the B cells and you have the T cells. B cells come from the bone marrow. That's why we call them B cells, from the bone. T cells come from the thymus. The thymus, remember, that's right around your Adam's apple, your thyroid area. Okay? And these two come to the lymph nodes. And that's kind of like their storage spot. And they are then sent through the body. And their goal is to sense an invader, to sense something that's not supposed to be there, and attack it. And defeat it. Now, they're very specialized, right? So in other words, if Christy is the T cell that is going to fight off the common cold, though that's a bad example because there's 1,000 different ways of that. The rhinovirus, let's say, or the bacteria, and Guyun is the one who's fighting out the mumps, right? They will not both attack me. If I am a mumps, she will attack me. If I am the other virus, she'll attack me, right? They're very specified. That's why we give vaccines. A vaccine's job is this. They provide a little tiny bit of that substance that would make you sick. Usually it's not active. In other words, they've killed it. They've just taken the parts of it that would cause Christy to react. And then your body begins to make Christies. Makes those B cells and those T cells to attack that specific.
So if it does happen, does it happen?
So that when it happens, you won't get sick. Okay? But when I get in those vaccines, sometimes it can cause a little bit of a reaction, right? You get a little bit sick sometimes from that, sure. Because again, your body is responding to, it's like you've gotten this attack, this sickness that's attacking you. Sir?
Are there foods that do the same thing as vaccines?
Are there foods? In other words, can I eat something to become immune?
Not the same thing as vaccines, but that can make those T cells and B cells aware of, I don't know, if they, without having to put the actual sickness in you, make the T cells and B cells strong enough to defeat it if the sickness comes in you. Like because grapes and apples, something on an article that I read that if you eat them, then you won't get a cold as much. And I read it, and my mom started giving us, gave us grapes and apples since we were very little.
Sure.
And we were little, we never had colds.
Nice.
After we stopped eating them when we got older because we got tired of them.
He's already getting cold. Gotcha. I think that there are some foods that do improve the functioning of the nerve system. I don't know if it's necessarily right for one type of bacteria or virus. I'm unaware of that. But yes, there are foods that do help build up the immune system, make it work better, definitely. Okay? So again, I am not looking for deep detail here as far as how the immune system works. What I am wanting you to know is you've got these B cells and these T cells that attack specific, they call them antigens, these bad things, the bacteria, the environmental things, the viruses. Because those things want to invade the cell. A virus basically wants to come and hijack a cell, turn it off, and turn it into a virus. So it produces more viruses, and then it sends them out. And those viruses then come and hijack another cell, make themselves, and send them out. And this immune system protects against that. And I mean, that's a 15-minute description of what's a lovely chapter that talks about a lot of good stuff. Questions there?
Would we also include the book says?
I'm sorry?
Would we include what the book says too?
Include what the...
About immunity, like just say just specific pathogens?
Right, that's what I mean by these specific things. Yeah, sure. Realize, of course, your immune system can also start attacking yourself, like your own cells. We call this an autoimmune disease. Well, no, that's acquired immunodeficiency syndrome. That means your immune system is suppressed. It doesn't work. These T cells in particular just get wiped out totally. That's what AIDS does. So you don't die from AIDS. You die from another infection that your body can't fight off. But let's say Andrew's body suddenly flipped and thought that his own cells were bad things. It could start producing these T cells and B cells to attack his own cells. That's what these autoimmune disorders are. It means your body is killing itself. Not a good thing. Very tough to recover from some of those things. Because you basically have to trick the body to say, no, these are okay. These are not bad cells, these are good cells. Or sometimes it's so powerful you have to just shut down the immune system as much as you can, which then, of course, leads you into other problems. Questions there? Lymphatic system. Just the briefest of briefs. Okay, last but not least, let's go to urinary system then. That's on page 468. If you want to go there with me. Page 468. So, urinary system. A little bit ahead of myself. Here we go. Urinary system. What's its job? Like, what's its function? What's that? Eliminate wastes. Okay, let's be a little bit more specific. Okay. The circulatory system also gets rid of wastes, right? The blood. What waste is gotten rid of in the blood?
There was
Carbon dioxide, right? That's one of the biggest wastes that we produce from our cellular respiration, right? Remember back in our lovely citric acid cycle, right? Carbon dioxide was one of the big products of this. So that's one way we get rid of that. But there are other wastes that we produce, in particular salts and other nitrogenous, in other words, nitrogen-based wastes. And that's what the immune system does. Not the immune, the urinary system does. It also helps, what else does it say there on page 468? Good. Normal concentrations of water, we know what that is. What's an electrolyte? Something that conducts electricity, but it usually is an ion, yes, like potassium and sodium. These things we need for your muscles to work and your nerves to work, right? Regulates the pH of the body fluids and also controls red blood cell production and blood pressure. But the big thing is the wastes, right? Reusing water and getting rid of wastes. That's really the two big functions of the urinary system. What are the main pieces of it? Well, this picture right here. The main two things that work in the urinary system are the kidneys. The kidneys are like filters, right? So the blood is sent through those kidneys. Remember on our cats how those kidneys were just almost solid red or blue? Because they're just filled with blood vessels. That's their main thing, is all the blood comes to the kidneys. And it's filtered through these little things that we call nephrons. That is, on your sheet, it says what is the functional unit of the kidney. That's the nephron. Functional unit means what's the thing that's actually doing the work, right? So So a nephron, you got this kind of squiggly area with this long tubule, this loop that goes up and down here. And that tubule is covered in blood vessels. Can you see this? Arteries on one side, arteries in quotes, these are just very small, tiny little blood vessels on one side, and then the veins on the other side. So it's a way that we can take and send that fluid down through. As it's pulled out of the blood vessels, it gets sent down through this loop. As it moves down, as much water as possible is taken out. As it comes back up, these waste products are taken back out. And those are absorbed then and sent down through the bladder. Am I making sense? So if we drink lots of water, there's lots of water present in our bodies. During this process, the kidney doesn't have to take all the water back out, right? Because there's enough of it. There's plenty of it going around. And so therefore our urine is clear. That's how you know you are hydrated. If you have clear urine, you're good to go. If the urine is not clear, that means in this process, your body has had to take and loop your urine back through these nephrons and keep taking the water out, because your body needs a certain amount of water. Does that make sense? You have to have it. So therefore, it's going to keep making your urine more and more concentrated to get the water it needs, right? As everybody reaches for their water to drink. I like it. It's good. Okay? So therefore, if we are dehydrated, if we don't have enough water, you get this very dark, very concentrated urine. Have you ever been to the zoo and been around some of these desert animals, like some of the desert cats or the camels or these kind of things? Their urine is extremely strong smelling. Why? Because their kidneys function very well to get almost all of the water out of that urine, and you're just almost pure wastes being expelled because the water is so precious, so valuable. It is very stinky. Yeah. Okay. So those kidneys, the drainage from the kidneys are these tubes that we call the ureters. So that nephron is hooked into this other tubule here that's going to drain down. All these millions of nephrons all through this whole kidney on both sides, right? Which drains down into the bladder. Your bladder is nothing but just a storage tank. Otherwise, you would be constantly having this very small stream of urine that would be coming out because your body is constantly filtering this blood. And so the urinary bladder is just it's a holder. Do you remember what was cool? It's a holder.
I want A+.
It's a placeholder. You remember what was cool about the tissue that the bladder is made of? Transitional epithelium. What was cool about it? It spans. It's elasticy, right? Which is pretty clever. So that as this thing starts to fill up, it can expand, and then it starts to trigger you. Hey, I got to go to the bathroom. And if you ignore it, it keeps filling up more. Hey, no, I got to go to the bathroom. And you can still control it, but there becomes a moment when if I made you sit in that seat and not ever leave, you would just go. There becomes a point where that bladder has to empty itself, right? I am not aware of that happening, no. It would just cause significant discomfort. And truthfully, your kidneys would stop working because it would back up. You know what I mean? You'd have this fluid back up.
So is it not able to pee?
It is not Well, let's say this. There's not any student that I have met that's ever had any trouble with this. If, in other words, you all are much more likely, it seems, to, can I go to the bathroom during class instead of just hanging out for 20 minutes until we finish? You know what I mean? Right, which you won't. Which you won't. Which you won't. My wife, on the other hand, is one who would go the whole day without going to the bathroom. And then say, oh, well, I got to go. And then it's like, oh, my, I got to go. And quickly go. So.
And the dialysis machine is like, it's when, is it like hooked up to your body?
It is. So dialysis means they put a little port up here, right where the aorta comes off. Remember there's a subclavian artery that ran right here? They put a port in there which basically pulls that blood directly out. And they run it through a fake kidney. And they take out all these wastes and then put the clean blood back in. Quite a long process.
My granny used to have one, a port in her,
Yeah.
but now they did something where they like rewired her vessels in her arm, and it's called a graft, and so they put
Nice.
her on instead of,
Oh, very nice.
these get infected.
They do, very easily.
So she was in and out of the hospital all last year, but now they just have the graft.
Interesting. Okay, cool. Very nice. So there, and again, because this is, you are having some outside thing that is in your artery forever. Like basically, as long as you need dialysis, you have to have this.
Isn't
So.
there a rollie to roll or the big machine?
No. It's a big machine. It's a sitting. Yeah, you go to this basically dialysis center where you sit in this nice comfy recliner for 3 hours while they filter your blood. And depending on how sick you are, maybe that's a once a week, maybe it's a twice a week, maybe it's an every day. Just depends. Yeah. No, kidneys are a big deal. Now, can you survive with only one of them? You can. You can. Well, I mean, it puts a little bit of strain on the other one, but you can live with it. Because people donate kidneys, you know. I'm sure you would. Certainly initially, afterwards, I don't know about permanently. I don't think so. I don't think so. I would imagine you would have to be very cognizant about drinking more, but I truthfully don't know. I've not dealt at all with any kidney donors or kidney transplants in my career, so I can't answer that. Are we 50, 12:50? We're done? Man, we're just rolling today. We're doing good.
Did you say that the ureters are just like transport?
Yeah, they're just a tube that's basically taking that urine, the filtered, the waste that comes out after being filtered, down to the bladder, and the urethra carries it out. Good. The last thing we did not get to talk about is the adrenal glands that produce epinephrine and norepinephrine. Do we see these? Gotta find this here. What page is it on? Maybe they don't talk about it here. How about you just know that they do those two things, eh? And I'll find it here for you. I thought it was here in this chapter. Epinephrine and norepinephrine. Yeah, we'll talk about those. I want to show you the bladder. There's a this is on in your chapter here. Where was the bladder at? Why won't you keep going? There we go. Page 483. So this is obviously a male bladder, right? How do I know it's a male bladder? Because it has that prostate, right? Females don't have prostates. Well, they have a little gland, but it's not in the same spot. Okay? So again, the urine would drain through those ureters, collect here. There's a nice muscle there. There's a sphincter. That's what potty training is, teaching you to use that sphincter. Right? To be able to hold, to control your urine. To not release it until you are on a toilet. Or in the woods someplace. Or wherever you choose to use the bathroom. Hopefully not in class. Okay? Very good. I will see you upon the morrow.